Hi, Namaste everyone. Welcome to my channel Excel Maths and Board. Today we will see plus 2 CBSE Standard 12 differentiation. Okay, let us consider these sums. Basically, we know the formula which is given in the NCERT book. As and when the formula is required, it will be written and it will be explained. Okay. So now here I have written three formulas for using which I am going to proceed with the sum. First question, y is equal to 3 sin x minus 4 sin cube x. So that is the question given us, and you are supposed to find dy by dx. Then prove that dy by dx is 3 cos 3x, and there is also one more subdivision. So the same question, it can be done in many methods. So let us try to solve it. Find the solution for it. Okay, so what is given? Y is equal to 3 sin x. Y is equal to 3 sin x minus 4 sin cube x. This is what is given us. He is asking me to find dy by dx. Normally, when we are very conversant with the trigonometric formula, immediately we'll try to substitute this as formula. But suppose if in the exam we don't know any formula and this is sin x which you can differentiate and this is sin cube x, this also can be differentiated. Normally the children once seeing the sum, how will start proceeding is dy by dx is equal to 3 differential of sin x is cos x and differential of sin is cos and differential of x is 1 minus 4. First comes the power rule, correct? So this is 3 sin square x. So first I have differentiated the power. Then I should go with differential of sin is cos and differential of x is 1. So this is how we will write at the answer as. So this can be written as 3 cos x minus 12 sin square x cos x. But it doesn't sound good. But when the question is asking you to differentiate, even if you differentiate like this, there's nothing wrong in it. Now, so let us leave the answer as such as of now. Now the same question. If the question is dy by dx and you have proceeded like this, there is nothing wrong in it. You can leave the answer as such and it will be a 2-mark question where you will be awarded 2 marks. But if the same question reads as prove that dy by dx is 3 cos 3x. So then I have to rearrange this in such a way that I get the required answer. Suppose you don't know any trigonometric formula, then what should be done? I am continuing with the second subdivision now. Now in this 3 cos x is common in both. So try to pull out. So 3 cos x, if I remove it, it is 1 minus 4 sin square x. Okay. So again, this is 3 cos x. This 1 can be written as cos square x plus sin square x minus, so this 1 is written this way, minus 4 sin square x. Again, this is 3 cos x into cos square x minus 3 sin square x. Yes, again, which is 3 cos x minus 3, this sin square x is written as 1 minus cos square x. See how complicated it is because you don't know what is the trigonometric formula for the given sum. That is how where we make the mistake. For this sum, if you know the trigonometric formula, you could have directly proceeded with the first step. So this is written as 3 cos x minus 3 plus 3 cos square x. I am just removing this bracket. This is also cos square x, right? So I am just removing this bracket and multiplying it inside. So this becomes 3 cos x into 4 cos square x minus 3. 3 into, I am pulling this cos x inside. So this is 4 cos cube x minus 3 cos x, which is 3 into cos 3x. I have arrived at the formula. But again, this is one method of doing. But look here, children. Prove that dy by dx is 3 cos 3x. Simply, you look at the answer. The first subdivision dy by dx, find dy by dx, and you have ended up with this answer. It is well and good. Okay, nobody is going to question you. Up to this, if you leave it as answer, it is fine. Nobody is going to question you why you did it like this. But இப்போ இதிலேந்து I have arrived at section B. But there is one more method of doing section B. For that you have to look at the answer, what he wants. Look at the answer, dy by dx. Prove that as 3 cos 3x. Prove that as 3 cos, there is only one term, 3 cos 3x. When will you get the answer as cos? When I differentiate sine, I will get it as cos. Correct? So think before you start doing. So again I am writing the question for subdivision B in another method. So now question number B. So y is equal to 3 sin x minus 4 sin cube x. Looking at the answer, I am thinking what is the identity. So this can be written as sin 3x. So when I differentiate y dash or dy by dx, differential of sin is cos and differential of 3x is 3, which I have arrived at. So this is just one step. If I could identify the correct identity. So how to recall? So if you look at the question again, differential of sin the cos. அப்போ இது அதுவும் ஒரே ஒரு term தான். There is only one term in the answer. So think of rewriting the question as one term so that you will end up with the answer fast. Find, okay. Now let us move on to the third subdivision. Find dy by dx at x is equal to pi by 3. So here I have got the answer, dy by dx at x is equal to pi by 3. So section C. So y dash at x is equal to pi by 3 is 3 cos 3 into pi by 3, which is cos pi. Cos pi is minus 1, so it is negative 3. This is the answer. Is that clear? So the same sum can be done in such a lengthy method, or it can be done straight in one shot. So it depends how convenient you are with the formula, or even if you don't know the formula or you have a little bit of confusion, you can look at what the answer demands and accordingly you can think and recollect. Try to recollect the formula. If you forget that, then you cannot do anything. But at least by looking at the answer, you could recollect at least what the formula can be, or you can be confident of, okay, this is the formula, right? Now we'll move on to the second sum. Find the derivative of sine of sine x square. So let me consider the given question as y. Y is equal to sine of sine x square. Now I want dy by dx derivative. So dy by dx is equal to differential of sine is cos. Okay, differential of this sine is cos. Then I should differentiate that x term, sine x square. Okay. Now here it is over. Now this is cos of sine x square. This is done. Now d by dx of sine x square. Now again differential of sine is cos, and again I should differentiate x square. So slowly I am moving. First I did this, then I did this, then I am going to differential of x square. So this can be done as cos of sine x squared into cos x squared Differential of x square is 2x. So this is what is the answer as. Now he is asking you when x is root pi by 2, what is the answer? So dy by dx at x is equal to root over pi by 2 is cos of sine x square, so pi by 2, into cos of x square, again pi by 2, into 2 into root over pi by 2. So this is sine pi by 2 is 1. So this is cos 1. Cos pi by 2 is cos 90 0 into 2 root pi by 2, which is 0, because any number multiplied by 0 you get the answer as 0. So this is the final answer. Okay, so it is differentiation step by step. I'm going inside because it is function inside the function. So slowly you should do, because the formula clearly says d by dx of sine x is cos x. So first differential of sine is cos. Then you have to differentiate this x term dx by dx. So I have applied that concept here. So differential of sine is cos. Then I have differentiated this here. Is that clear? Now let me move on to the next sum. It is very simple. Y is given as 3x square minus 5x plus 7 whole power 7. Find dy by dx. So dy by dx is, first I should apply power rule, right? So this n x power n minus 1. So that is the formula which is being applied. So n x power n minus 1 into d by dx of x. In the place of x only I have 3x square minus 5x plus 7. So the answer becomes 7 into 3x square minus 5x plus 6 plus 7 whole power 6, and differential of this is 6x square, 6x, not x square, so 6x minus 5. So this is the final answer. Hope you are able to at least view how. So in case of trigonometry, wherever the identities or formulas are available, try to make use of it. If you are not able to catch it properly, check what the answer demands. Accordingly, you have to simplify the trigonometric equations or whatever is given. Then if you proceed, it will be easy for us. Hope you have understood it. We'll catch up in the next video. Thank you. Bye.